Okay, this is just a quick video to talk about some useful results that are not in your textbook. So this first one is if you have the mean or expected value of ax plus b, it's a times the expected value of x plus b. So for example, if you wanted to find the expected value of 3x plus 4, it'd be 3 times your mean plus 4. Okay, and here's the proof of that. So let's just have a little look at the proof. So we know that expected value means add them up multiplied by the probabilities. So I've just expanded out that sum. So your first score times the probability of the first score, second one times probability of the second one, and so on, up to your last one. And then I've just expanded out these brackets. Okay, so that times that and that times that. I've expanded out those brackets and I've expanded out these brackets. Now I've collected up all the values there that have an A in front of them. So this one, this one, this one, and I've factorised out the A, and then all the ones that have a B in front of them, and I've factorised out the B. Now the cool thing here is that bracket there, that's the sum of the probabilities, and we know the probabilities always add to 1, so that's just 1. So this thing here is the expected value of x, so you do have A times the expected value of x plus B. Now if B was 0, that would be much more simplified down to this thing here. For variance, we have a similar result. If you've got ax plus b, you'll just get a squared variance of x. So the b just disappears. So if you were finding the variance of x plus 4, then that would just be 9 times the variance of x. So let's just have a quick skim through the proof of that. So the variance is the expected value of the score squared minus the mean of those things squared. So notice over here we've got mu there, that's just the expected value of x. So here we need the expected value of ax plus b and all squared, which is equivalent to this part, but with the ax plus b. Okay, I've just expanded out that square there, it's a perfect square. And I did apply the result that we had above in that bracket there. Now, expected value, we saw above that those things can be separated out. So you've got the expected value of the first thing plus the expected value of those two things separated, minus, and I've just expanded out that perfect square there. Now, we saw above, I can pull the a squared out here. This thing here, I've just separated it into 2 from that result above. And then I've just factorised, expanded out that bracket with the minus. So the b squares cancel out, these terms here cancel out, and you're just left with those ones. They've both got an a squared in front of them, so factorised, we have this, and that thing in the brackets is the variance of x. To prove these results, or to demonstrate these results, I should say. So I'll just show you what this spreadsheet is I've got so far set up. So I've given some scores for x, and I've got 2 copies of it. If I change it at the top, say to 7, you'll see down here it changed to 7 as well. So these top numbers are always going to be the same as those numbers. Now my probabilities here, just in that third one, I do have a formula to make sure that they all add to 1. So if I change this 0.3 to a 0.4, my 0.6 is going to change to a 0.5, and you'll see they change down there as well. So at the moment, the 2 data sets are the same. Now I'm going to calculate the expected value, or the mean. So I'm going to do this times this plus this times this plus this one times this one. So our mean or expected value is 5.9. Notice if I change this back to 0.3, the mean is now 6.1. Now I'm just going to copy and paste that exact same formula down here. It's going to be finding the mean of this one. Now at the moment A is 1 and B is 0 in these data sets because this has not been changed. But I just wanted that formula in there. Now to find the variance, of course, it's equal to this number squared times this probability plus this number squared times this probability plus this number squared times this probability minus the mean squared. So 1.29 now for the variance, and again I'm going to copy that formula down to the one at the bottom. Okay, now I'm going to change the values of A and B. So instead of this formula just saying equal to this number here, I'm going to change it. Firstly, I'm just going to not worry about B and just use A. So I'm going to change it to A times that number. So in here, I'm going to put the number that is in D1 multiplied by this number. Now that D1, as I drag across, I don't want it to change to E, F, G, so I just need a dollar sign in front of the D to fix it at a D. And I will drag that formula across. Oops. So now each of these scores is 3 times those. Now have a look at the expected value. It's 3 times. Let's just double check that by dividing them. So equals this one divided by this one. And sure enough, that is a 3. And let's do the same thing with the variance. Let's equals this number divided by this number. And that's 9. Now, if I change that 3 to another number, you can see the mean has been multiplied by 4, the variance has been multiplied by 16. Okay, let's put a value for B in there as well to demonstrate these results. So as well as being 4 times this, I'm going to add this number here. Again, I'm going to need a dollar sign for when I copy it across. So this 21 is now this number here multiplied by 4 plus 5. So 16 plus 5 is 21. Let's drag that formula across and see the result. Now dividing the means, I've got some random number here. We can see that dividing the variance, I've got that A squared. This result is holding true. The B is having no effect on it. It's just A squared. Oh, there's a typo there. Sorry. It's just A squared times the variance of X. So the plus B made no difference whatsoever in terms of the ratios of these variances. It did make a difference for the mean. So I'm just going to change this formula. What I'm going to do is I'm going to do this number here multiplied, I'm just doing this right hand side, multiplied by that plus this number here. And you can see that I get this same answer here. So the mean of this second set of data is equal to this one times A plus B. And that demonstrates that first result is true.